Elastic potential store. This is the energy store associated with an object's ability to be stretched or squashed and then return to its original shape. So we have an equation for this. EE, which is energy elastic potential, is equal to 1/2 KE squared, where K is the spring constant, which tells us how stiff or loose the spring is, and E is the extension. That means how far the spring is either stretched or squashed. It's important to note it doesn't just have to be a spring though. It can be a rubber band, or it could be, as the example on the screen, a bow and arrow. So let's take a look at how the energy depends on each of these quantities. First of all, we have our spring constant K. We have two springs here. One of them, on the right, is extremely stiff. This is a suspension spring, whilst the one on the left can be easily squashed. So in this case, we have that K2, the one on the right, is greater than K1, the one on the left, which means the energy in the elastic potential store of the second spring will be greater than the energy in the elastic potential store of the first spring. This is simply because the one on the right is stiffer than the one on the left. Next, we have the extension. We have a bow and arrow on the left with 0 extension, and we have one on the right with a larger extension. So we have E2 is greater than E1. This means that the energy in the elastic potential store of the second bow and arrow is greater than the energy in the elastic potential store of the first bow and arrow.